Building blocks of the Internet. The Internet, as we know it today, is a vast and intricate web of interconnected networks, servers, and devices. But have you ever wondered what makes this global communication system tick? Written by Andrew S. Tannenbaum, the book Computer Networks is a cornerstone in understanding the fundamentals of how these networks operate. It delves deep into the principles and protocols that form the backbone of the Internet. Imagine trying to understand a complex machine without a blueprint. It would be like trying to assemble a puzzle without knowing what the final picture looks like. It would be incredibly difficult to figure out how all the parts work together. This is where the importance of structured models comes into play. In the world of computer networks, the OSI, Open Systems Interconnection, and TCP/IP models are our blueprints. These models provide a systematic approach to understanding the complex interactions that occur within a network. They provide a structured framework for understanding how data travels across the Internet, from your computer to a website on the other side of the globe. This journey involves multiple steps and layers, each playing a crucial role in ensuring data integrity and delivery. These models break down the complex process of Internet communication into smaller, more manageable layers. Each layer is responsible for a specific aspect of the communication process, making it easier to understand and manage. Each layer represents a specific stage in the data transmission process, with its own set of rules and functions. For instance, the physical layer deals with the actual hardware connections, while the application layer focuses on the end-user software. By understanding these layers, we can better grasp how computers communicate and troubleshoot any issues that may arise. This knowledge is essential for network engineers, IT professionals, and anyone interested in the inner workings of the Internet. It empowers us to build more efficient, reliable, and secure networks. Unpacking the OSI model from bits to applications. The OSI model, or Open Systems Interconnection model, is a conceptual framework used to understand and implement network protocols in 7 distinct layers. The OSI model is the more comprehensive of the two, consisting of 7 layers. These layers are physical, data link, network, transport, session, presentation, and application. Think of it as a layered cake, where each layer builds upon the one below it. Each layer has its own specific function and communicates with the layers directly above and below it. Data travels down through these layers on the sending device, then back up through the corresponding layers on the receiving device. This ensures that data is properly packaged, transmitted, and received. This layered approach offers several advantages. It provides a clear structure for network communication, making it easier to design and manage complex networks. It simplifies network design and troubleshooting, allowing developers to focus on specific layers without worrying about the others. This modularity helps in isolating and fixing issues more efficiently. It also promotes interoperability between different vendors' equipment, ensuring that devices from different manufacturers can communicate seamlessly. This is crucial in today's diverse and interconnected tech landscape, where compatibility and communication are key. Physical layer, the foundation of data transmission. At the very bottom of the OSI model lies the physical layer, responsible for transmitting raw data bits over the physical medium. This layer defines the physical characteristics of the network, such as cable types, connectors, and electrical signals. Imagine sending a message by flashing a flashlight on and off. The physical layer is like the flashlight, the light bulb, and the batteries. It deals with the physical transmission of the light signals. Data link layer, ensuring reliable data transfer. Moving up, we encounter the data link layer, responsible for reliable data transfer between directly connected nodes on a network. This layer packages data bits into frames, adds error detection and correction mechanisms, and manages media access control (MAC) addresses. Continuing our flashlight analogy, the data link layer is like adding Morse code to our signals. It defines the structure of the message and ensures that it's transmitted correctly, even if there's interference. Network layer. Routing data packets across networks. The network layer deals with routing data packets across multiple networks. It determines the optimal path for data to travel from source to destination, using logical addresses like IP addresses. Think of this layer as the postal service. When you send a letter, you don't need to know the exact route it takes. The postal service handles routing, ensuring your letter reaches its destination. Transport layer. Managing data flow between devices. The transport layer manages the reliable and efficient delivery of data between applications running on different devices. It segments data into smaller packets, acknowledges receipt, and retransmits lost packets. In our postal analogy, the transport layer is like choosing between sending a regular letter or a registered letter with tracking. It provides different levels of service depending on the application's requirements. Session layer. Establishing and managing connections. The session layer establishes, coordinates, and terminates conversations or sessions between applications. It handles authentication, synchronization, and checkpointing, ensuring that data exchange is orderly and reliable. Imagine you're having a phone call. The session layer is like the dialing and ringing process, establishing the connection and managing the flow of the conversation. Presentation layer formatting data for application use. The presentation layer ensures that data is presented in a format understandable by the application layer. It handles data encryption, decryption, compression, and conversion between different data formats. This layer is like a translator between two people speaking different languages. It ensures that both sides can understand each other. Application layer. User interface to the network. Finally, we reach the top layer, the application layer. This layer provides a user interface for network applications, such as web browsers, email clients, and file transfer programs. It interacts directly with users and applications, allowing them to access network services. This layer is like the person writing and reading the letter. It's the interface between the user and the underlying network infrastructure. Putting it all together, how the models enable internet communication. The internet, as we know it today, relies heavily on structured models to facilitate seamless communication between devices. These models break down the complex process of data transmission into understandable and manageable layers. The OSI model provides a comprehensive framework for understanding network communication, consisting of 7 distinct layers, each with its own specific function. These layers range from the physical layer, which deals with the hardware aspects, to the application layer, which interfaces directly with software applications. However, in practice, the TCP/IP model is more widely used. This model simplifies the OSI model by collapsing some of its layers, making it more practical for real-world applications. The TCP/IP model collapses the top 3 layers of the OSI model into a single application layer, which handles all the functions related to application, presentation, and session layers. Additionally, it combines the session and presentation layers into the transport layer, which is responsible for end-to-end communication and error checking. Despite their differences, both models serve the same fundamental purpose: to enable seamless communication between devices across the internet. They ensure that data is transmitted accurately and efficiently from one device to another, regardless of the underlying hardware or software. By breaking down the complex process of data transmission into manageable layers, these models allow for a modular approach to network design and troubleshooting. Each layer can be developed and improved independently, leading to more robust and flexible network systems. These models have been instrumental in the development and growth of the Internet. They have provided a standardized approach that has enabled different technologies and systems to work together harmoniously. Understanding these models is essential for anyone working with computer networks, from network administrators to software developers. It provides them with the knowledge needed to design, implement, and maintain efficient and secure networks. By grasping the roles and functions of each layer, professionals can better diagnose and resolve network issues, optimize performance, and ensure the security of data transmission. By understanding the intricacies of each layer, we can better appreciate the complexity and ingenuity of the digital world we inhabit. This knowledge empowers us to innovate and improve the technologies that keep us connected. The models not only help in understanding current technologies, but also pave the way for future advancements. As we continue to rely more on digital communication, the importance of these models will only grow, guiding us towards a more connected and efficient world.